Hey, what's up guys? So this video is the second part for the test review for section 7.1, 7.2, and 10.2. So my first video covers questions 1 through 12. For this video, I'm going to start with question number 13, and I'm going to finish with question number 25. So let's look at number 13. So here, number 13, you guys are going to have to multiply the exponent outside times the exponents inside of the parentheses. Notice that we do have numbers, coefficients, and they do have an exponent of 1. The 9 on the bottom has an exponent of 1, and the variables also have an exponent. So this 2 here, you guys multiply times the 1, times the 4, times the 7, and the bottom you also multiply by the exponent of 2. So when you guys multiply, the exponents keep the same base. So the 2 on the top says the same, but you multiply the exponents. 2 times 1 is 2. The x stays the same, and you multiply the exponents. 2 times 4 is 8. And the y, you multiply the exponents. 2 times 7 is 14. On the bottom, you have a 9, and you multiply the exponents. 2 times 1 is 2. And the z, multiply the exponents. 2 times 2 is 4. Once again, the bases x, y, and z are not the same, so you cannot simplify, but we're able to simplify the coefficients, the 2 squared and the 9 squared. So the top will be 2 squared is 4, keep the x to the 8th, y to the 14th, and on the bottom, the denominator, 9 squared is 81, and we have z to the 4th power. So this is my answer. 14, you guys have 2 parentheses, and in the middle, look at the middle. I know there's an exponent of 4, but there's no plus or minus in between the parentheses. So that means that you are multiplying the 2 parentheses. But we also have those exponents outside of the parentheses. So first, we need to multiply those exponents times the ones inside. So let's do that first. I'm going to take the 4, this exponent in the first parentheses, and I'm going to multiply by the 3. And remember that b has an exponent of 1. So I'm going to multiply that 1 by 4. So you guys keep the base. There's the a. 3 times 4 is 12. And the b, 1 times 4 is 4. But I am going to multiply. Let me put the times, the dots, which means multiplication, in the middle. And then I'm going to multiply by the second parenthesis, or the second monomial, but I need to distribute or multiply. It's not really distributive property, but you multiply the exponents. 3 times 5 and the 3 times 3. So you guys keep the base. There's the a. 3 times 5 is 15, and b, 3 times 3 is 9. So since you're multiplying and we do have the same bases, look at the a's, look at the b's. When you guys multiply the same bases, you keep the base and you guys add the exponents. So let's do the a's first. A to the 12 times a to the 15. Keep the a and add the exponents. 12 plus 15, that's going to be 27. And b, you guys have b to the 4th and b to the 9th. So you guys keep the b and you guys add the exponents. 4 plus 9 is 13. So my answer is right there. Now 15, you're also multiplying. There's nothing in between here, but we do have an exponent outside of the parentheses. So before you multiply the monomials, you guys need to multiply the exponents for the second parentheses, the second monomial, by the exponent outside. So the first one stays the same. Since I don't have anything outside the parentheses here or over here, I'm just going to bring this down, and I don't need the parentheses anymore. So I'm going to put negative x to the 7th, y squared, but I will multiply, and let me distribute the exponent, or once again, you multiply the exponent. So we have 4 times negative 2. And notice the negative, it is inside the parentheses. Okay? So we do have a negative 2. And you guys will multiply the exponent of the 2, which is a 1, times the 4. So that's going to be to the 4th power. The x, you multiply 4 times the 6. That's going to be 24. And the y, 4 times 2, that will be 8. Now, you guys can simplify right here. We have a negative 2 to the 4th power. Remember, when the negative is inside the parentheses and the exponent is even, your answer will be positive. And 2 to the 4th power is 16. So I know it's going to be positive 16. You guys have the x to the 24th power and the y to the 8th power. Over here, well, we do have a negative x to the 7th and a y squared, and you're multiplying. Now remember, this negative, it actually has an invisible 1 here. So we have a negative 1x to the 7th. So let me put the 1. So that means you're going to multiply the negative 1 times the 16. They're numbers, they're coefficients. So I'm going to multiply those two numbers. Then you guys are going to multiply the same bases. So we do have the x to the 7th and the x to the 24th. Keep the base, and you guys add the exponent, 7 plus 24. And then the y's, you guys have a y squared times a y to the 8th. You guys keep the base, and you guys are going to add the exponents, 2 plus 8. So let's go back. Let's multiply negative 1 times 16. That's negative 16. When you guys have x, you add the exponents. Exponent of 31, that's for the x. And the y will be 10. So my answer is all of that. 16 is moving to radicals. You guys need to simplify radicals. So you need to understand the exponent of 1/2. Exponent of 1/2, that means the square root. So you guys can change that exponent to a radical, which is the square root. So we're going to have the square root of 20. 20 is not a perfect square number. So you guys cannot find the square root of 20 without a calculator. And we're not looking for decimals, but we need to simplify the radical. So I'm going to look for two numbers that multiply to 20, and I'm thinking of 2 times 10. There's options you guys can use. 4 times 5 also multiplies to 20. But as long as the numbers multiply to 20, you guys will get the same answer. So 2 times 10 is 20. The 10, you guys can break it down to 2 times 5. And the 2 and the 5 are prime numbers. So you guys cannot break those numbers down. So now we're going to start making pairs. So I have a pair of 2's right here. So that pair is going to go outside of the parentheses. So we have a radical. One pair of 2's means you put only one 2 outside. Inside, you guys write down the number with no pair. So we have the 5 inside of the radical. So my answer will be 2 square root of 5. 17, same thing. You guys have 72 to the 1/2 exponent. So 1/2 exponent means square root, and I have 72. 72 is not a perfect square number, so I'm going to have to break it down. So I'm thinking of 8 times 9, that's 72. 8 will be 4 times 2, and the 9 is 3 times 3. 4, you can break it down again, 2 times 2. And we can make pairs. There's a pair of 2's right here, and there's a pair of 3's over here. And in the middle, we have a number 2 with no pair. So outside of the radical, I'm going to have my 2, the pair of 2's, and I'm going to multiply it by the other pair of 3's. So you put 2 times the 3. Inside, you put the number with no pair. So you're going to multiply 2 times 3, that'll be 6. And inside of the radical is going to be the 2 that doesn't have a pair. So my answer will be 6 square root of 2. 18, you guys have the square root, not an exponent of 1/2, so it's already a radical. But if you notice, we have the square root of 64. This number, it is a perfect square number because we can find the square root of 64 by multiplying 8 times 8. 8 times 8 will give you 64. So that means that the square root of 64 is the number 8, because if you guys square that number, it will give you guys the number inside of the radical. So if you guys are able to recognize perfect square numbers, that's going to help you guys a lot when you guys simplify radicals. So 64 is a perfect square number, 25 is a perfect square number, 36, 4, 16, 81, 100. So there's many perfect square numbers. So if you guys are able to recognize those numbers, like I said, it will be easier to simplify the radicals. 19, we're going to use the product property, which means you are going to multiply radicals. There's nothing in between here, the 3, the square root of 3, and the parentheses. There's no plus or minus, and we have parentheses, so that means you're going to multiply. So first, you will multiply the numbers outside, the 4 and the 3. So I'm going to put 4 times 3. Then the product property says you can multiply the numbers inside of the radical, the 3 and the 18. So inside you multiply 3 times 18. So outside of the radical, 4 times 3, that'll be 12. Inside of the radical, 3 times 18, 54. Now notice, guys, inside you guys have a 54. You guys have to check if you can simplify the radical. Outside the 12, you're going to keep it because you guys cannot do anything to that number. But 54, I'm thinking of 9 times 6. That's 54. The 9 is 3 times 3. Oh, guess what? We can make a pair of 3s right there. If you guys break down the 6, that's going to be 2 times 3. They do not have a pair. So the only pair that we have is the 3, and we can put that outside of the radical. But remember that 12? We're going to have to multiply 12 times the 3 that we're going to take outside. So outside of the radical, I have the 12 times the 3. Inside of the radical, we keep the 2 times the 3. So 2 times 3, that's going to be 6 eventually. But you guys will multiply 12 times 3 outside. That's 36. Inside will be 2 times 3 is 6. So my answer is this one. 20 has a radical with a fraction. So this is going to be using the quotient property. So first, you check if you guys can simplify the radical, the fraction inside of the radical. So you guys can. You guys can simplify by 5. You can divide both numbers by 5. So this will be the square root of 1 over 5. Now that you're going to have to separate using the quotient property the top and the bottom of the fraction. So I'm going to keep the fraction line. You take the square root of 1 on the top, and the bottom will be the square root of 5. On the top, 1 is a perfect square number. So the square root of 1 is 1, but the bottom, 5, is not a perfect square number, and it is a prime number. So you guys, when you have a prime number inside of the parentheses, you cannot break it down. So the top will be 1, the square root of 1 is 1, but the bottom will stay the same, square root of 5. Keep in mind that on the bottom of the fraction, we cannot have a radical. So to get rid of the radical, you're going to multiply by itself. So you're going to multiply by the square root of 5. And whatever you do to the bottom, you guys will do it to the top. So the top of the fraction, 1 times the square root of 5, that's going to be just the square root of 5. And the bottom, you guys can multiply the numbers inside. 5 times 5 is 25. But then you guys have to take the square root of 25, which is 5. Now the trick I show you guys, when you multiply a radical by itself, you just keep the radicand. So there's the 5, only one time. And that's going to be the bottom. You guys cannot divide the square root of 5 by 5 because they're not like terms. The 5 on the bottom doesn't have a radical. So that's the answer right there. 21, you guys are simplifying. There's a 6 outside and there's a 75, which is not a perfect square number inside of the radical. But we need to check if we can break it down and make pairs. So 75, I am thinking of 25 times 3. That's going to be 75. 25 is 5 times 5. So we can make a pair of 5s. That's a prime number. And 3 is also prime and it doesn't have a pair. So the number outside of the radical, you guys have to keep it. So I'm going to put the radical first. I'm going to keep the 6 and I'm going to multiply by the pair of 5s. So the 5 goes outside, but you guys need to bring down the 6. Inside, you guys will have the 3. So you guys have a 3, square root of 3, and then you guys multiply 6 times 5. Outside of the radical, that's 30. And then we have square root of 3. So my answer is 30 square root of 3. So 22 is using the product property again. We are multiplying the two radicals, and since the two numbers have a radical, we can multiply those numbers inside of the radical. So you keep the radical. 3 times 45, that's going to be 135. Now you guys need to check if you guys can break down the number. I noticed the number ends with the 5, so I know 5 has to go into that number. So I'm going to try the 5. So it's going to be 5 times 27. 27, you guys can break it down to 9 times 3. And the 9, you guys can break it down to 3 times 3. So I can make a pair. I can make a pair of 3's here. And this number 3 doesn't have a pair. And the number 5 doesn't have a pair. So I'm going to keep the radical. The 3 goes outside, the one that has a pair. And the 5 times the 3 goes inside of the radical. So this is going to equal 3 square root of 15. Now 23, you guys have a fraction, but notice that the radicals are already separated for you on the top and the bottom. So you guys don't have to worry about making two radicals, one on the top, one on the bottom. You just have to simplify the fraction. So the top, I noticed that 16 is a perfect square number. Yes, it is. Because 4 squared is going to be 16. So that means the square root of 16 is 4. Now at the bottom, 7 is prime. So you guys cannot break it down and you guys cannot simplify. So you keep it the same for now. And I'm saying for now because we have to get rid of that radical. So I'm going to multiply by the same radical on the bottom. And whatever you do to the bottom, you do it to the top of the radical. So the top, remember that when the number doesn't have a radical, the 4, just like the 4 doesn't have a radical, you cannot multiply 7 times 4. So you're just going to put them side by side. Okay? So we have the 4 square root of 7. And on the bottom, remember when you multiply the radical by itself, you just keep the radicand. So it's just going to be 7 on the bottom of the fraction. So there's my answer. So 24, you guys have a fraction, but this one is not separated like 23. So we're going to have to use the quotient property. I'm going to separate the top with the square root of 55 and the bottom with the square root of 144. Check the bottom. This number, 144, is a perfect square number. So you guys can simplify the bottom to 12. The square root of 144 is 12. The top, well, let's check. Let's check if we can make pairs with the 55. So I'm going to do it down here. You can do it on the side of the paper, but I'm going to write down the 55. I know that 5 times 11 is 55. 5 is prime. 11 is also prime. And guess what? We cannot do pairs. So that means that we cannot simplify that square root. So you guys keep it the same, square root of 55. It stays the same. So my answer is the square root of 55 over 12. 25, the square root of 64 over 256. Well, first of all, guys, you notice the numbers are perfect square numbers. 64, the square root of 64 will be 8, and the bottom is also a perfect square number. So you guys can use the quotient property, the square root of 64 on the top, and the square root of 256 on the bottom. So the top is going to be 8, because 8 squared is 64, and the bottom is 16. So here's a tip that I'm going to give you guys. If you notice, the numbers are perfect square numbers. That's why it's very important that you guys are able to recognize those numbers. If they're perfect square numbers, you can find the square root of the numbers just like this. But then, guys, make sure that you check. Can we still reduce the fraction? This one, 8 over 16. Yes, we can. We can reduce by 8. So you guys divide the top and the bottom by 8. You always want to simplify it if you can. So 8 divided by 8 is 1. 16 divided by 8 is 2. So my answer is 1/2. All right, guys, so this concludes the video. Make sure you guys get prepared for the test. If you guys like my videos, you guys can click that like button. And you guys can also subscribe to my channel. Make sure you also check the first part of the test review. And make sure you guys practice. And I'll see you guys later.